Hello friends, welcome to the third lecture on D and F lock transition element. Let us have some recap for the previous two lectures. That is the lecture number 1. We have discussed about the classification of the D block element, and we have understand that there is a four series of D block elements: 3D, 4D, 5D and 6D. And we have discussed about the general configuration of transition elements. We have discussed about the what is the definition of the transition element, why we call it is a D block element, and also we understand that all the D block elements are not the transition element, but all the transition element is necessarily the D block element. That we have discussed in the first video. In the second second video, we have discussed about some physical characteristics like atomic radius, ionic radius, then metallic property, then melting point and boiling point. We have discussed, and also we have discussed the enthalpy of atomizations. So in this video, that is lecture number 3, we are again going to discuss three very important characteristics of the transition element, D block element. That is, the ionization enthalpy we will first discuss, then we will discuss the density and the thermal stability of the transition element compounds. The three things we are going to discuss. So heading up to this lecture, that you can say that physical properties of the transition element, that is a part 2, and we will be going to discuss the respective one that already I have told to you. So this is K.K. Mukherjee, the Science with Mukherjee Sir YouTube channel. So first we are going to discuss the ionization enthalpy. We know what is ionization enthalpy. We already studied in our class 11, that is in the chemical bonding chapter. Ionization energy is nothing but the energy required to remove one or more than one electrons from the isolated gaseous state atoms or ions. So we will going to discuss what will be in the case of a transition element. So far we have discussed about it in case of representative elements or main group element, main block element, you can understand. So what is the difference between these that we are going to discuss? Now if we want to compare with the S block element, P block element about this transition, about the ionization enthalpy, that is I am talking about the first ionization enthalpy. Ionization enthalpy is basically, and that depends on the state of the oxidation state. That ionization enthalpy, when we are talking about the first ionization enthalpy, it is found the D block element will have the higher ionization enthalpy than the S block element, and it is also lower than the P block element. Straight away we can able to see. But what is the trend when we concentrate focus on the D block elements of the different series? That you can easily understand from this table. In this table, this is given the different that is a 3D element, where 3D transition element we are talking about, that is the 10 elements that is being given here. To understand this ionization enthalpy, it is required its electronic configuration also. So it is here that the number is given, the 10 elements is been given here, and along with this the electronic configurations. So what we understand from this table, that you can easily see that as we go across the series, or we can say when the nuclear charges is increasing, in which that it is accompanied with the electrons has been fielded in the inner d orbitals. So what is going to happen? there is a direct increase in generally we will say that it is been increasing. The ionization enthalpy you can see, and it is been kilojoule per mole. It is unit is basically kilojoule per mole. How much energy is required to dispel 1 electrons, that is from this neutral atom, that is ionization enthalpy 1, first ionization enthalpy. So in this case you can see that there is a continuous increase of the ionization enthalpy as we go from the left hand side of the series to the right hand side of the series. So you can see this, that is there is a continuous increasing. And the last element, that is zinc, has the highest first ionization enthalpy, that is 906 kilojoule per mole. But here is some abnormality, some discrepancies we can see. In case of chromium, you will see that is here whatever as the you can see as the atomic number is increasing, there is an increase of the ionization enthalpy. But here we see increase is there, that is not so appreciable, that is not so significant. Why it is so? This is due to this fact, when it is chromium plus ion, at that time this 1 electron from the s orbital has been removed, but there is no disturbance in the d orbitals electrons, and that is why it has been lower ionization energy we will observe. Otherwise there is no such abnormality we can observe in case of first ionization enthalpy. But when we are going to the second ionization enthalpy, that is when 1 more electron has been removed from the ions, that unipositive ions, at that time what we find, you can see there is also, you can see that the trend is same, that as we go from the left hand side to the right hand side of this series, what we find, there is a continuous increase of the ionization enthalpy. This is the second ionization enthalpy, and here you can see that chromium has, you will find that chromium has the very high second ionization enthalpy. If we compare with this first ionization enthalpy, it is very high. Why it is so? It is because of the fact that when this 1 electron is removed, that there is no electron in this 4s orbital, it is 0, 4s 0. At that time, you have to remove the electrons from this 3d5, and you can see 3d5 is a very stable one, and when there is a stable thing is achieved, it is very hard to change this stability. That you can easily understand. I can give you one very good example. As per an example, suppose your father is doing here in the Calcutta. Suppose he is doing job, he is stable here, and company says you have to go outside of West Bengal. So what is going to happen then? Then he will be little bit disturbed because he is in the stable state. Now he has been ordered to go outside, that he will be unstable state, and that also happened here also. The electron in the most stable state, it is a most stable configuration. We know that is a half-filled set of orbital, a full-filled set of orbital, that is the most stable state. So when you are remove the 1 electrons from these stable electron configurations, then what is going to happen? You have to put lot of energies, and that is what happened. You can see it is a very high ionization enthalpy, and this also you can see also in case of copper also. Copper is a very high second ionization enthalpy, because when Cu plus 1, you have to remove this electron from the ions, that is U plus 1. So at that time, here 3d10, this is the stable electronic configuration. So you can same cheese apply. What is applicable here in the chromium? Same cheese is applying here. that you have to remove this electron from the most stable state of conditions. So here again you have to put lot of energy, lot of efforts. For that, this second ionization enthalpy is very, very high in case of this. At the same time, another thing you can observe, for this, if you analyze this, that for the zinc, this second ionization enthalpy is less. Why? For the zinc, it will be a stable arrangement. It will go to the 3D10. 3D10 is a very, very stable arrangement. Suppose, reversely, if we think someone is outside, staying in outside, and he has been told you go to your West Bengal, our West Bengal branch, so you will be satisfied because he is going to the stable situation. And this things is here that 3D, when two electrons is being removed, it will now this electronic configuration much more stable. So you have to give him, you have to put less energy. So that is why zinc ionization enthalpy is less. Okay, so we understand the first ionization enthalpy is less than second ionization enthalpy. Again, third ionization enthalpy, you can see a very important thing that here the three elements, that is nickel, this and this, you will find that is a very high ionization enthalpy. Why? Again, we can understand from this electronic configuration means when we want to remove this electron from the d orbitals, that is again a stable arrangement, and it is going to give us the higher third ionization enthalpy. Normally you cannot observe this oxidation state at a Cu3 plus or Zn3 plus. This oxidation number never you can able to see because it is so energy efficient, so energy consuming that you will not be able to do that. But if you see for the iron, if you see here the iron having the comparatively lesser ionization, third ionization enthalpy. Why it is so? Because when it is Fe3, you can see its configuration is 3D5, and this 3D5 configuration is very, very stable configuration. So Fe3, that is the third ionization enthalpy of the iron, is lesser because of achieving the stable arrangement. So we understand this very important fact that this ionization enthalpy of the transition element is not a regular feature. There is always a abnormal behavior, and that is due to its electronic configurations. Sometimes we want to remove these electrons from the stable state of affairs, that here you can see here is stable state, and you have to, for this chromium has the higher second ionization enthalpy. Okay, so we understand. Now one thing that we can able to understand, the third ionization enthalpy is very much higher than the second ionization enthalpy in the third ionization enthalpy. Okay, I think so. Ionization enthalpy of the third series that we have, that the third 3D series, that we understand very well, and that is a very, very interesting thing. Now we are going to discuss the density of this transition element. Now we are going to discuss the density. Density of transition elements, that you can easily understand as we go across the series. What we find, density is gradually being increases, but here in the case of zinc it is slightly lower, that is it is having the weak metal bond. Here you can see density goes on increasing. That is here Fe you will find 7.8, copper it is a maximum 8.7 and 8.9. Among the three series there is one element, it is iridium. Iridium having the maximum density, that is 22.61 gram per centimeter cube. This is gram per centimeter cube. So iridium and also osmium have the density that's 22.59, and lowest density is of the scandium. So this is very easy to understand that density, that is a result of the metallic property, that is higher, more metallic property having this transition will have, and this is going to have this trait. And sometimes the questions, different type of small questions will come, which that the nickel and copper is both having the same density. So now we are going to discuss another very important property. That is the Now I will discuss the thermodynamic stability of the transition metal element compound. And this is a rule that when the ionization enthalpy is less, at that time the compound will be more stable. Compound shall be more stable. So it relates to the ionization enthalpy. As for example, the first ionization enthalpy plus second ionization enthalpy, the sum of these for the nickel and platinum is given, that is one is 2.49 10 to the power 3 kilojoule per mole, and platinum having 2.63 10 to the power kilojoule per mole. So nickel 2 compound of nickel to oxidation state will be more stable. Than platinum 2. Another example, that is this is for the nickel and platinum respectively. It is found 1.49 into 10 to the power 3, and it is 9.43 into 10 to the power 3. So in this case, platinum having the 4 oxidation number is stable. It is more stable. Stable than nickel 4. So in the complex compound you will find K2PtCl6 compound is more stable, but you do not find this compound is not known, NiCl6. This compound is not known, so this is more stable thermodynamically. Okay, so that is all for today's lecture. In this lecture we discussed very important some physical properties of the transition metal element. First we have discussed the ionization enthalpy. In second we have discussed the density, and third the thermodynamic stability of the transition metal element compounds, and how we can able to ascend, and how we will to say about this that we have discussed in detail. So that is all. Hope all the points clear to you, and we will visit the next lecture. Thank you very much for watching.